Hello everyone and welcome to today's webinar. For today's webinar, we'll be talking about load and energy management with Fronius inverters. For the webinar today, it will be myself, Byron Kutzer. I am the Technical Sales Advisor of the Southern African region. And joining me today is my colleague, Cyprian Okulu, who is the Technical Sales Advisor for the Western African region. In today's agenda, we'll be covering load management, energy flow management, as well as energy management with the 4 IOs that is available on the Fronius inverters, the wiring and configuration that will be required, maximizing the self-consumption with your Fronius inverters, as well as utilizing the Ohm Pilot, which is our thermal storage solution, as well as our Watt Pilot, which is your EV charging, and then your storage with the Fronius Gen 24, as well as any further information will be provided at the end of the webinar. Before we start, feel free to ask questions during the webinar in the chat box down below. And lastly, your opinion is important to us, so we will greatly appreciate any feedback with regards to today's webinar. So to start us off, we will be talking about load management. So next is the load profile analysis. So this is when you are making use of the 3 options when controlling different loads with the Fronius Gen 24, for example. So we'll use an auto manual switch, or we'll be using the plug power point that is available, which is a 230 volt AC power adapter, as well as utilizing our external relays. So for example, this is a typical graph that you would see in SolarWeb itself. So here we can see our normal loads during the day, and then we have a massive spike of a peak load during the day. The red box is indicating when you are charging an EV vehicle, for example. So this is when we'll then make use of our RS485 from our smart meter to our Fronius inverter, and our IO control to open relays to then allow for those peak loads to then be charged or utilized differently. So again, what required components are in the system? You'll have your Fronius Gen 24 or Snap Inverter series, as well as your Fronius smart meter, which is required when doing this, as well as doing an analysis in SolarWeb to fully utilize the system. So if you are doing a wall box controlled by the Fronius load management, so this is that external box that's 230 volt AC that's coming out of the inverter, this is when you'll make use of it. So this is showing how the other loads are during the day. So you've got massive peak loads from 2 o'clock in the afternoon onwards. And this interrupted is the EV charger. So this is when we are then making utilization of that wall box itself to then pull 5 kilowatt peak of savings in a sense. With the load management on the commercial side, so this requires designing the PV power to cover loads such as air conditioners on a sunny day, and also integrating of 2 EV charging points with a maximum of 22 kilowatts, which is then controlled by the Fronius load management output. So the target here is to avoid peak loads of higher than 50 kilowatts for the system itself. So here we are reducing the charging power so that we are not fully peaking the load itself. And then also here at the end of the graph, where it's 7 o'clock to about 8 o'clock, we are then reducing the charging power again. So this will help to turn off one of the EV chargers or using the EV charger with integrated load balancing in the sense. So why is peak load balancing important? So it avoids higher consumption costs. So the customers with peak load measurements, as well as avoiding high costs of network adaptations. So no charge of network cables or fuses, and as well as the possibility of higher EV charging output. So this is when the integration of your PV and the battery storage in the system, you'll then have a much greater possibility of charging your EV vehicle much faster and more efficiently. So next is the load management itself. So on the higher self-consumption. So this is when you have logged into the data manager itself and want to initialize the load management page. So here we have 4 different settings of the digital IOs. So we've got threshold settings. So we've got it on, which is our feed-in power, which is the load power itself, and as well as the off function, which is on the base load consumption. So this therefore indicates that when you have a base load of higher than 100 watts, for example, then we can then utilize our load management in that sense. So we are covering our base loads for the time being, and with the PV surplus that we have available, we are then utilizing the load management to then cover those higher loads in the system. So here's the next example of when you're doing peak load balancing. So this again is referring to when it's on, it is the feed-in or the low consumption, and off is when the consumption or the peak load level, as well as the minimum duration as short as possible when setting of your load management. So here we have a feed-in of 1.1 kilowatt and a consumption value of 3 kilowatt. So what this refers to is if the consumption or your basic loads go above 3 kilowatts in the household, for example, or the system, this load management would then disable itself to then cover those base loads then reoccurring, for example. So how would you activate this using on a Gen24 or Taro unit? This is helped utilizing the solar.start app. So here is the different features and pins that are available. So here is your IO pins. We will just simply initiate the load management, and then we need to make sure that the correct pins are assigned. We'll then do the same controlling priority. So we'll do power by surplus. So this is in case of feed-in limits, which is common in a lot of countries at the moment. We'll then have to then set our thresholds itself. So we've got an operating mode of on. So we'll have a feed-in of 1.5 kilowatt. And for the off operation, we'll have a consumption value of 1 kilowatt in the system. So this is an example of the settings with the peak load balancing with your EV vehicle. So this is the settings of the threshold with the PV surplus with 4 kilowatt feed-in limit. So here we can see as the off threshold is for when we are starting to push back into the grid, for example, or we have a consumption load. And here we have the PV surplus. So it shows that we are then utilizing 2 kilowatts of PV surplus to then help with the EV charging power itself. As well as for the activation without the PV surplus. So here we have a base load of 4 kilowatts, for example, and we are then fully utilizing that 4 kilowatts for the EV charging itself. So that's why it's very utilization of the feed-in limits and as well as your PV surplus to then help cover those excessive peak loads during the day. So next is the Fronius energy flow management. See what PV system with the smart meter and data manager. So this is your load profile analysis. So the inverter will utilize the data manager if it's a snap inverter series, or with the Gen24 or Taro, it'll be the pilot card. They will then utilize this with the Fronius smart meter to then help do a load profile analysis of the system. With controlling of heavy loads, so this will be under the load management itself page. So this is when utilizing for air cons, pool pumps, borehole pumps, any high demanding peak load that switches on and off, for example, or has a set duration that you want it to run during the day, you can then utilize that under the load management. The next is the battery storage. So this is when you're then making use of the battery storage through your BYD or through hot water storage, so as the Fronius Ohm Pilot, to help then save energy at the end of the day. So you've got different control options of loads. So here we have load management, which is utilizing the IOs to control the loads. So its purpose is to increase the self-consumption, so to turn on reducing peak loads, and then to turn off when it is complete. And then also utilizing your dynamic power control. So this is stepless control of your surplus power to the battery or storage, and your Fronius Ohm Pilot to generate hot water, and the Watt Pilot for the EV charging. So its purpose is to increase your self-consumption again also, but also to avoid peak loads in combination with the battery storage in the system. So the benefits of energy flow management. So you can increase your own consumption and self-sufficiency. You can use cheaper night tariffs if you've got variable tariffs in the country that you are living in. You also avoid expensive power from the grid because you're self-sufficient in that sense. And also simple standard components. So there's no additional control devices are required. It's all built in already and it's software designed, integrated into the Fronius inverters itself from standard. Next is the energy management with the 4 IOs. So here we are doing a simple example with a snap inverter series, which has got the 4 digital outputs, which are 12 volt DC, which are integrated as standard. So here we are utilizing a EV charging. We are also using the big consumers such as water heating or air cons, or we are then utilizing for a pool pump and also the air conditioning itself. So these 4 digital IOs, we can separate them into each individual high consumption load that is on the system itself. On the wiring side, so this is on the interface of the snap inverter series, so your Primo, Simo, and Eco inverters. So the 4 digital IOs, as well as your smart meter, which is on Modbus RTU. So here we'll then utilize the pins for IO3, IO1, IO2, and IO0. And your smart meter will then be communicating in D plus and D minus, for example. So you're then utilizing only this section of the IOs. On the Gen 24, it's very similar. Again, you're utilizing IO0, IO2, IO1, and IO3. It's exactly the same. So next is if you have a single phase with the relay circuit. So for example, if you're using an electric vehicle or pool pump. So from here, from the IO pin, we'll use 1 and 0. So it's positive and negative. Through 12 volt into the relay, which will trigger depending on the load management profile that you've set, which will then open for that load to then be allowed to be switched on, for example. So the external relays, so for example, we use the Fiddler relay or Waldmüller relays. So the technical spec, so its normal operating power of all 4 digital outputs is 3.2 watts, which is consumption. And then it's all 12 volt DC nominal voltage on the relays. For the configuration, you're utilizing your IOs. So next is we have the web interface. So you'll simply need to log into the inverter. So go into the setup page, enable the Wi-Fi access point, log into the inverter using the password 1234567 and then enter into your web browser, the IP address 192.168.250.181 on your device. Then you'll then go under the IO mapping and then enable load management, and then control which pins you're then utilizing. If you're using all 4, it's standard, it's normally enabled. But if you're only utilizing 1, for example, we can close out those pins and it'll, also display which pins are currently in use. Next, we'll then go onto the load management page. And from here, we'll then set the load management profile that we were wanting to achieve. So if it's by a PV surplus, in case of the feed-in, for example, we will then set the thresholds for the system itself, as well as the durations if required, and as well as the desired duration. So if, for example, we leave the house at 9 o'clock in the morning, for example, we can set load to then switch on from 9 o'clock onwards, so that when we know that the base loads are very low, we can then make use of our load management. Importantly is to set the prioritization of the system itself. So you'll need to go under the load management also and just check that the load management is set as the highest priority. Next, for example, is the threshold. So the settings example. So this is a threshold setting with small grid consumption. So here we can see we have from 0 to 3 kilowatts is for feed in. So this is when we'll have it switch on, for example, and then we are charging our EV vehicle. So we are making full use of that PV surplus to then help charge our EV vehicle. Then the threshold without grid consumption. So here example is we've got 1.5 or 1.2 kilowatts available, and we'll then utilize this surplus to then switch on to then cover our pool pump power that has been designed. So this is preferably with smaller loads. So next is the runtime settings. So we have a minimum runtime. So this prevents two frequency switching due to rapidly changing irradiation. Next is the maximum runtime. So this is the runtime per day. So for example, the pool pump not necessary to run for more than 8 hours, for example. So we can say it must run for a maximum of 2 hours, for example. We can then set that duration, as well as the target runtime. So this is a specific moment in time up to which a defined period of runtime is to be switched on. So for example, the target is for the pool pump to run for 4 hours to ensure good water quality, or we can set the target runtime before the sunset to avoid using power from the grid. Next is application examples. So here we can have the prioritization is set on load management with IO1, which has got a 1 kilowatt pool pump in the system, which has to run for a maximum duration per day of 3 hours. Next is our battery, and then lastly is our own pilot, which has got 9 kilowatt heating rods. So here we can see the prioritization where as long as we've achieved the 1 kilowatt, we are then covering our load management, which is our set as our highest prioritization, which is the pool pump itself. Then from 1 kilowatt onwards, we've got a PV surplus. So then we are then utilizing the battery prioritization to make sure our battery is fully charged. Once we have covered that SOC of 99%, for example, we are then covering our warm water, which is on our own pilot, as we have excess power, which is then normally being fed back into the grid. But in this case, we are using it to then heat up our water within the heat pump. And then later clock, we've got obviously no PV generation available. So then we are utilizing our battery itself to cover our normal loads. For example, so this is when we are using two load management IOs. So we're using IO1, again with a 1 kilowatt pool pump, again duration of 3 hours per day. And it's utilizing the IO2, which is the wall box with a 3 kilowatt activation threshold, and then a negative 1,000 kilowatt deactivation threshold, and as well as our battery and own pilot with 6 kilowatt heating rods. So again, it's very similar. So as soon as we achieve the 1 kilowatt threshold, we are then utilizing our pool pump to then be utilized. Next is our battery itself. And then last is our e-mobility car. In the system itself. And then our battery is then fully charged up until 1 o'clock in the afternoon. And that is when we can then utilize the remaining power available in the system to then utilize the own pilot with the heating of the water. Next, Cyprian Okulu will be taking over from here on.
Yes, indeed. Thanks a lot, Byron, for a wonderful presentation. First part of this webinar. I want to believe that can all see my screen and hear me clearly. So if so, let's continue. Yeah, so in the same light of the topic, which is load and energy management, we want to continue showing you how you can actually maximize self-consumption, because In our view, it is the best way you can actually manage your load and, of course, energy consumption. So to do this, we are going to be going three-pronged. That is looking at how we can achieve this using the thermal storage solution, e-mobility, and battery storage solutions from Fronius. So let's start up with the thermal storage. But then before we do that, of course, we have to show you or tell you the motivation or why this is absolutely necessary. So just for a start, we're looking at how the control options are with respect to achieving this. So just like Byron has actually mentioned in his own part of the presentation, we can actually achieve this via the input-output ports, where we can be able to control heavy loads via the integrated input-output ports. So in this case, heavy loads are powered using surplus PV energy. In the same way, through the Fronius load management regime, we can actually activate and make use of a heat pump, which are smart grid ready. So the heat pump also is controlled using, of course, when there is surplus PV energy, and thereby attaining our target temperature, water temperature that is. And then through dynamic control, which in this case, we can make use of the home pilot and then trigger heating rods that will, of course, help in generating hot water. So, but then why this? Because there definitely has to be a scenario that would want to prompt us to achieve this. So now let's take a look at the typical PV production curve. Now, a good look at this would show us that, yeah, so we have a battery storage solution here on the SolarWeb production curve, as you can see. So for this particular production curve, we can see that as soon as the sun rises and then PV starts to be produced, we can see that the battery starts charging at about 7 a.m. and then it takes it about 3 hours or less to achieve maximum SOC, that is full state of charge. So afterwards, nothing else. You can see that this whole green region is actually pumped into the grid, as you can see. So this entails that there is little or no self-consumption because a high proportion of the PV generated is being pumped into the grid. Okay, so that said, it is true that when you feed into the grid, you are going to get payments for it. So now let's have a critical look at that. So why do we need to increase self-consumption? So this is basically the motivation, looking at the price. So this is a chart between 2013 and 2017. So we can see that with time, the energy tariff with regards to the feed-in tariff, the space is actually increasing. You can see that what you actually pay to use the grid is quite high than what the grid gives you in return for feeding into the grid. As you can see, we have instead of, with relation to 22 euro cents per kilowatt hour, we tend to feed in at 5 euro cents per kilowatt hour. So let's take example of this particular curve that we saw earlier. We can see that most of all the PV generated is actually pumped into the grid, all for 5 euro cents per kilowatt hour. And then at night time, that is outside the PV production time, when you need to use the grid, then you now tend to buy it for more than 4 times what the price was when you fed in. So by looking at it, you want to believe, or you know that this is basically not economical. So what can be done? The best thing to do is, of course, to increase self-consumption. And then how can it be done? We have to look at shifting your load consumption regime. or times that you use some heavy loads in the house. Of course, this would come with load management and then stepless control of your surplus power that is fed into the grid. So instead of feeding into the grid, you can of course use it to generate hot water for later use, to charge your EVs for later use, of course, and then of course charge your battery, which can also be used during when PV is not or no longer being generated. Good. So after seeing the motivation, the reason for it, and how this can be achieved, let's now take a good look at the ways that we can achieve this. Before I continue, I must mention here that these solutions have actually been discussed in pretty detailed form in dedicated webinars. So please, you do well to visit our YouTube channel, where you can get pretty more information with regards to these solutions, just in case you don't get everything here. So this is just basically to give us an outlook on how these solutions can be achieved using these methods. So for thermal storage, basically we make use of an accessory called the Fronius Home Pilot. So what the Fronius Home Pilot does is to communicate with the inverter, of course, through the smart meter. This tells when there is surplus energy, that is basically when you're producing more than you're consuming, and then the surplus energy can now be used to generate hot water. So what Home Pilot does basically is to sense when there is surplus energy with, of course, the communication via the communication line, of course, with the inverter, and then the surplus energy would now be channeled. So what the Home Pilot does is to trigger the heating rod in the hot water tank, and then this now helps in generating hot water to a target temperature. And I must say that the application is actually only meant for ohmic loads. Ohmic in the sense that we mean purely resistive loads. Good. So looking at some of the features of the Home Pilot, yeah, you can actually steplessly control powers from 0 up to 9 kilowatts using the heat rod, of course. So you can actually come in a single or 3-phase setup. So with this, you can actually achieve it. Excuse me. So just to summarize, you can have a single phase up to 3 kilowatts and then 3-phase up to 9 kilowatts. So in case you have surpluses of, say, in case you're having a base load of, say, 2 kilowatts, if you have this setup, you can actually make use of either the single phase or even the 3-phase if you're generating more, to control and then to make use of this surplus energy to generate hot water. And then the beautiful thing here is that you can actually use this to control more than one heating rod. In fact, you can control up to 2 heating rods with it, and then has a very, very flexible means of communication, either via Wi-Fi, or also known as wireless LAN, or Modbus RTU. And then, of course, it is conformable with EMV communication protocols. And then you can also use this in combination with other heating sources, meaning that if you have a primary heating source, say probably coal, let's say, you can actually integrate this seamlessly into it. So what this does, say in periods of, let's say winter, when we don't have much PV generation, this can actually also be used. So what it does is basically to complement the primary heating source. Good. So let's quickly look at the working principle. So what it does, as indicated, is to steplessly control surplus energy. So let's have an example here. We have an example here for generation of 1.5 kilowatts, and then the base load is consuming, say, 1,000 watts. That's 1 kilowatt. So that means we have 500 watts extra or surplus. So in a situation where we don't make any use of self-consumption regime, this extra 500 watts is being fed into the grid. But then if we now want to implement self-consumption with making use of Fronius own pilot, so what this does is instead of channeling this 500 watts to the grid at say 5 euro cents per kilowatt hour, you can actually make use of it to heat up your water so that you don't have to buy it back 4 times more expensive than you sold it initially. So you can make use of the 500 watts to heat up the water to some certain level of convenience, as much as what your surplus power can help out with. So let's take a scenario, a real-time scenario of, say, provision of hot water for 4-person household with a 300-liter hot water tank, and then having an installed 5 kilowatts PV capacity. So this 5 kilowatts, when channeled completely, would be able to produce 150 liters of hot water at 40 degrees Celsius. And then this basically is the minimum power supply during cloudy days or during winter, per se. And then if you're now able to generate 17 kilowatt hour or obtain or get 17 kilowatt hour from your self-consumption regime, this would be able to give you 300 liters of hot water at 60 degrees, which is usually the maximum power supply at sunny days. So we can see that this is from the numbers, this is something that can be easily attainable. So having a look at a day curve, whilst implementing the load management as earlier recommended, you can now see that by adjusting your load usage regime, we can see that we'll be able to achieve most of our energy consumption targets within the PV generation period, as you can see. So the red region, of course, you can see it's used to generate hot water at 11 kilowatt hour energy. Using that to obtain hot water of a 200 liter capacity. And then, more importantly, you can see that your heavy loads are also being implemented during this PV generation period. So instead of making use of these heavy loads outside the PV generation region, it makes more sense to use it during the PV generation period so that you can achieve higher self-consumption percentage. Good. That's it for the home pilot or hot water generation. Let's now look at the e-mobility, introducing the accessory, Fronius accessory used to attain this, which is called the Fronius Watt Pilot. Now, the Fronius Watt Pilot is just like what the home pilot does, but in this case, it is implemented for EV charging. So we have 2 versions, the home version and then the mobile version per se, as we can see. Now, what it does basically is to replicate what the home pilot does, but in this case, using it to charge EVs, just as I mentioned in the previous slide. So once there is a surplus EV production, that is once you're producing more than you're consuming, the surplus can now be channeled via the Watt Pilot to charge your EVs. Of course, it has to be a very seamless communication between the Watt Pilot and the inverter to tell when there is this surplus energy, and then we can now maximize this in charging efficiently EVs. So this can be achieved by the use of the Fronius Solar Watt Pilot app. It's a standalone app that is very, very user-friendly, that upon commissioning, you can be able to visualize your installation and, of course, make certain settings option remotely, as you can also see. Good. So yeah, here is the very good part of it. You can actually use this to attain charging with different or variable energy tariffs. So we have different charging modes. One is the eco mode, then one is the next trip mode. I'm going to tell you more about this in the next slide. So yeah, so eco mode basically, I think that will come in the next slide. But then just to give you a brief of what it's all about, you can actually achieve PV charging even when there is no PV available. But then this can be done in the most efficient manner, meaning that it will scan through and then choose the tariff period that charges the least, as you can see from this graph. So what it does is to ensure that in eco mode, it looks at the price level and ensures that you charge with the least available tariff plan, just as you can see in this particular illustration. I'll be giving you more instance or more, I'll be shedding more light on it in the coming slides. Another good thing about it is that you can actually achieve surplus charging automatically using either in the three-phase or in single-phase mode, because it can achieve surplus charging from 1.3 kilowatts up to 22 kilowatts. So it is fully automatic. You don't have to do anything. The system detects and is able to utilize this charging and of course automatically switching into these modes respectively. So having a look at this PV curve, you can see that once there's enough power available for charging in three-phase mode, it does that. And then once it drops to a stage where it can no longer support three-phase charging, it automatically switches into single-phase charging, as you can see. So yeah, let's now talk about how this works. So as earlier I mentioned, you can actually achieve it in a single phase and three phase. So you have it starting from 1.3 kilowatts up to 4.14 kilowatts as in minimum charging power capacity per se. So in the single phase mode, it can actually charge from 1.3 kilowatts up to about 7.3 kilowatts. And then in the three phase mode, it can actually charge from 4.14 kilowatts up to 22 kilowatts. So yeah, so like I mentioned, just to give you more detail about the eco mode. So what it does is basically to combine surplus PV and the usage of variable energy tariffs to charge your EV. So what it does basically is, as you can see, so it makes use of your surplus EV charging and then also makes use of the grid. But then what it does is to select or look for a time when the grid tariff is actually low or least, and then makes use of it to attain a target charging capacity of your EV. So that's what it basically does. Next trip mode. So that was for the eco mode. Next trip mode, it will be best to explain this using an example. So let's say you want to cover 60 kilometers to and fro tomorrow at starting from 7 a.m. for the lowest price, basically. So this is cost no problem. So what this charging mode does is to, of course, make use of PV when available, but then it will ensure that it charges up to the capacity needed to cover that particular distance. Okay, so this means that it might not, it is possible for it not to charge the EV fully. It will only charge it to the capacity that is necessary to cover the given distance. Yeah, so if the PV available is not enough to charge it to this particular capacity, it will now make use of the grid to now attain this particular charge capacity. So that's basically what this means. So we must note here that for the two modes, that is the eco mode and the next trip mode, these smart charging regimes are only available for now in Germany and Austria, but course, there is plans in place to ensure that these spreads are outside these given regions for now, countries for now. So yeah, so after looking at thermal energy generation and then e-mobility, let's now look at battery storage using the Gen 24 Plus. So with the Gen 24 Plus, we're able to obtain or achieve battery charging. And then this is, of course, possible with the collaboration with the BYD batteries for the HVM and HVS types. So you can, of course, achieve storage cascading with parallel mounting or parallel installation of up to 3 units or towers, and with high capacities up to 57.96 kilowatt hour. What is unique about this is you can actually achieve full backup capability and also high parallel charging and discharging. So, giving us a bit more detail about the Gen 24 Plus and BYD storage solution, just to tell you that this makes use of the lithium iron phosphate battery cell technology. It is retrofittable. We have 2 versions, that is the HVS and the HVM. The HVS comes in 2.6 kilowatt hour modules, while the HVM comes in 2.8 kilowatt module. So for the HVS, you would need 2 modules for a start, and then you can actually ramp it up to 10.2 kilowatt hour. Then for the HVM, you'll need 4 modules minimum, and then ramp it up to 4 modules, of course, will give you 11.2 kilowatt hour, and then you can now ramp it up to 22.1 kilowatt hour. That is up to 8 modules. Good. It is easily installed and then easy also to commission. Now to tell you more about multi-flow technology that makes this storage technology very, very flexible and easy to use. You can, of course, attain DC to AC conversion and power usage, that is from the PV straight up to the load point. Of course, if you want to feed into the grid, and if it is allowed, you can also achieve that. That is from DC to AC. And then you can also achieve DC to DC for charging the battery. And then, of course, in the reverse, DC to AC. That is when drawing power from the battery. It is also possible to have AC to DC from the grid, in this case, to, of course, charge the battery. And then, of course, you kind of have it retrofittable into an existing AC coupled system, as you can see. So, next up is the 3-phase backup power. So you can actually achieve full 3-phase backup power. So once there is no grid, you'd have your backup switch disengage, and then have your inverter now having the capability of injecting power or charging the battery from DC to DC, and then of course from DC to AC, that is feeding your load point. And then of course you can also achieve DC to AC from the battery to the load point. Good. So just giving you a brief detail in terms of the nominal power per phase and maximum discharging current, as you can see, both for the Primo, which is a single phase, and the Simo, you can of course achieve maximum charging and discharging current of 22 amps. And then of course, if you want to just to help with the calculation, depending if you're using single phase or 3-phase, you can now be able to obtain your designated power by, of course, multiplying current by the respective voltage in use. So for both the HVS and the HVM, it is possible to obtain up to 9 kilowatts charging and discharging power, as you can see, which is, of course, a very, very good number when it comes to even or as in to evenly charge and of course evenly distribute or discharge at a particular given power capacity. So let's now take a look at the UID storage combination matrix. Yeah, so just in case for those that might ask, okay, what batteries would I be able to use with the Primo and the SIMO? So here it is. So this is a combination matrix. So for the HVS to start with, you can combine this with the Primo Gen 24 Plus. That is for the HVS 5.1 and 7.7. So, but then for the SIMO Gen 24 Plus, you can make use of the HVS 5.1, 7.7, and 10.2 kilowatts capacities. How about the HVM? So for the HVM, you can make use of it with the Primo Gen 24 Plus. That is going from the HVM 11, 13.8, 16.6, and 19.3 kilowatt hour capacities. And then for the SIMO Gen 24 Plus, it's virtually all of them with the exemption of the HVM 8.3. So this is basically the chart of what we've been talking about. And then to note here, most importantly, is that the highest capacity you can achieve is the combination of three 19.3 towers of the HVM to give you a total of 57.96 kilowatts hour. Good. So that's basically a roundup of how you can achieve maximum self-consumption to help you in your load and energy management with Fronius inverters. Next up is to give you a couple of further information. First off is to tell you where you can easily get information from our website. We all know that Fronius actually has 3 business units. That is the welding unit, the perfect charging, or also called the charging unit, and of course, the solar energy business unit. So you could do well to click on the solar energy business unit. So once that is done, you can now go to, well, in this case, since we are basically communicating with mostly installers and partners alike, you can select the section that you would want to get more information on. There's also a section for business owners and for homeowners. So say you go in for the installers and partners, you would now have access to products and solutions, technical data, information center, service and support, download center, and of course, contact point. Yeah, so with this, you would be able to get virtually all the information you need with regards to a particular product or particular service. Yes, so this can be, you can actually get access to this from our website, which is www.fronius.com. Yes, so how can you get recordings? Yeah, recordings are available on our homepage where you can get operating and installation instructions using this link. Of course, on our YouTube channel, you can also get how-to and installation videos. You can also get webinar recordings. And then specifically speaking, you can actually have access to our Sub-Saharan Africa playlist, where you can get all the recordings of the webinars that we produce, including this one, of course, using this particular link. For further inquiries about technical questions, training, sales, and after sales, please do well to contact these details, as you can see here on the screen. But then if you want to have access to also contact the technical sales advisors, that will be myself, Cyprian Okolo, Byron Kotza, and David Mwangi. So please do so according to your respective TSAs for your respective regions, that is. So I cover the Western Africa region, Byron, the Southern Africa region, and then David is responsible for the Eastern Africa region. Good. So with that, we have come to the end of the webinar today. We hope you enjoyed the content, and yes, we're going to have a look at the questions you have sent and then provide the answers respectively. If for any reason we can't do that, we will definitely contact you via email and then give you your respective responses. So thanks once again for making our time to attend. And then until we come your way next time, do enjoy the rest of the day. Thank you.